This project was for CECS 525 Spring 2014. We are Group 2. Our project was a mixture of home automation and home security. We wanted to build a simple security camera as cheap as possible that also has the ability to remotely control some power outlets. Here we have our video camera. We have 3 commercially available remote controlled outlets, our Raspberry Pi, and the circuit we constructed. The Raspberry Pi only has a webcam USB connection, the power connection, and the Ethernet connection, so everything is done over SSH and through a network interface. I'm going to turn the camera over to Reese now so he can kind of explain what the circuit has or how it works before we continue.
Alright, so basically we have this commercially available remote which controls the 3 outlets we have. You see it has an on button and an off button for every outlet. Now on the back here we've opened up the remote and we've soldered in some wires to different points on the remote's circuit board. As you can see, this is the ground down here, right, leading up straight from the battery ground. And up here, through a bit of reverse engineering, we found out that these different points correspond to the buttons. You see, from right to left, we have the on for channel 1, the first outlet, and the off for the first outlet. We've given everything a different color so we can kind of keep track of it in the circuit. And then we have the on for the channel 2, and the off for channel 2, on for 3, and off for 3. All in that order from right to left. And what we're doing from the Pi is we're controlling these relays here. And these relays are sending 5 volts through the circuit to these different points. These points are activated on 5 volts, and when we tested that by, pressing a few of these buttons, seeing what points, go high when we press these different buttons, and we're basically forcing 5 volts onto these points to trick the system into thinking a button has been pressed. So the Pi controls a relay which flips when it receives the 3.3 volts from the Pi, and then it lets out 5 volts that we've gotten from an external power source through to the board itself and controls the outlets. And that's how the Pi controls that.
Alright, so without further ado, I guess we're just going to show you the web interface that we have built. Here it is running right now. As you can see, we're just pointing the camera at the 3 outlets. I'm going to refresh the page so we can get the whole user experience, so to speak. So as you can see, it was fairly fast on loading the video that time. Sometimes it'll take a while. So we're going to go ahead and turn on an outlet here. And there you can see the red light has come on channel 1, so we're going to go ahead and turn it back off. You may be wondering about why the text is unknown. Currently we do not have a way to actually query the outlet on whether or not it's powered up when the web page loads. There is no feedback loop available to us. So we're just going to go through and power on and power off each outlet. It's pretty hard to tell since we're looking at a static image with just flashing lights, but this server video feed is actually running at 10 frames a second. I believe it's 640 by 480 pixels and 75% image quality. So not the greatest, and the Pi is definitely crying right now under the heavy load, but we found that it works pretty well. So that is our project. Thank you.